So in today's session, I'll be explaining yet another clustering technique. This is the hierarchical clustering technique. So in the hierarchical clustering technique, the grouping of the data clustering is the technique which groups similar data into clusters. So in that sense, hierarchical clustering will try to group the data objects into tree structure. So the clusters will be in the form of tree structures. So that is the concept of the hierarchical clustering. So hierarchical clustering can be of two types, agglomerative and the divisive hierarchical clustering. The agglomerative hierarchical clustering is a bottom-up strategy, and the divisive hierarchical clustering is a top-down strategy. So in the bottom-up strategy, so this is the tree structure. In what fashion the clustering will happen. So assume that these are all the individual points. These individual points will be grouped into smaller clusters, and so these two is again getting grouped into another cluster, and these two is grouping into one cluster, and these two gets grouped into another cluster. So this is how the tree structure is formed. So the essence of the hierarchical clustering is to form some tree structure. So in today's session, I'm going to explain one example for the hierarchical agglomerative clustering, wherein given the data points, we will be able to find out the clusters. Like first we try to form the tree structure, and from the tree structure, we will try to get the clusters. So assume that the input data is given like this. A set of data points are given. So the procedure for the formation of this hierarchical tree, the agglomerative tree, for this clustering technique is based on the Euclidean distance formula. The Euclidean distance formula between 2 points, say xy and AB, is equal to square root of x minus a square plus x minus b square. So this is the formula for the Euclidean distance. So this is the basis for creating the distance matrix based on which the hierarchical tree for the clustering will be formed. So now say, so first what we have to do is we have to make this distance matrix. So first this initial distance matrix is formulated. So here there are 6 points, P1, P2, P3 up to P6. So we will be writing them in the rows as well as columns, P1, P2, P3, P4, P5 and P6. So P1 to 6 here horizontally and vertically as well, we will be writing the 6 data points, and we will try to calculate the distance between each pair of points. So it is evident that distance between P1 to P2 will be same as P2 to P1. So the it is sufficient that we calculate for one half of the triangle, whereas the upper triangular values are going to be the same. So we will not be doing the calculation for one half. So we'll be doing only for the other half of the pairs. And across the diagonal, it is equal to 0 because the distance between P1 to P1 is 0, P2 to P2 is 0, P3 to P3 is 0, and so on. So what we will be calculating only the distance between these pair of points. That is P2 to P1, then P2 to P3 to P1, P3 to P2, and so on. We will be calculating these values. So how is this value calculated? The distance between P1 and P2. So we have the 2 points here, data points P1 and P2. We refer from here P1 and P2. That is 0.4, 0.53, and P2 is 0.22 and 0.38. So we have these two data points. So just apply these two data points in the given formula. So applying these 2 points here, we'll be getting a distance value of 0.23. So we get this value of 0.23 here. So likewise, we take each pair of points and we calculate these values. All these values are calculated using this Euclidean formula. So now this table is complete. Now what we have to do is we have to pick the smallest value in this matrix. So the smallest value in this matrix, so you can ignore 0. You don't have to worry about 0. So from the non-zero value, whichever is the smallest value. So as far as this table is concerned, 0.11 is the smallest value. So take the smallest value and merge the 2 points corresponding to the smallest value into one cluster. So the 2 points corresponding to this 0.11 is P3 and P6. Column wise it is P3 and row wise it is P6. So P3 and P6 will be first grouped into one cluster. So henceforth the matrix will shrink because we will be having P1, P2. Instead of P3 will be having P3 comma P6 because P3 and P6 will be merged. So you won't be having a separate column for P6. So P3 comma P6, P4 and P5. Similarly, in this rows also there will be P1, P2 and there will be one combined row for P3 and P6 and there will be P4, P5 and there won't be any row for P6. So these values have to be now recalculated. So initially we formulated this table, we calculated the distance between every pair of points. So this table is this table. So the distance between each pair of points, and we identified that 0.11 is the least value. So we are going to club P3 and P6. So now you can observe in this table, second table, that we have clubbed P3 and P6. So there won't be any individual column for P3 or P6. Now we have to recalculate the values, but you don't have to recalculate all the values because this value is going to remain same and these two values are going to remain same and these two values are also going to remain same and this value is also going to remain same. So what you are going to recalculate is only these four values. So what is the distance of P3, P6 with P1, P2, P4 and P5? Only these four values we are going to recalculate because those four values are not available in the previous table. The other values are available in the previous table. We can just like that copy those values from the previous table. So these values will be just like that borrowed from the previous table. Only these four values will be recalculated. Only these four values where the merging has happened, only these four values will be recalculated. That is P3, P6 with P1, with P2, with P4 and with P5. So these four values are the calculation are shown here. P3, P6 with P1, P2, P4 and P5. These four calculations are shown here. So how this merging is happened? So now you don't need that Euclidean distance formula. Just you need to find the minimum. You need to apply only this what is it called as the logical minimum concept to find the minimum of the two distance. So the calculation will be only when you calculate the initial matrix. You'll be using this Euclidean formula to calculate the distance between each pair of points only when you populate the initial matrix. Afterwards, this values will be used as the reference values and the further values will be derived from the existing values only. So now we have to calculate these four values, that is P3, P6 with P1, P2, P4 and P5. So P3, P6 with the P1. So what we will be doing is we will be finding out the distance between P3 and P1, P6 and P1. So P3, P1, P6, P1. We will be fetching these two distance from the existing table, and we will choose the minimum of these two as the value for this particular cell. So what we'll be doing is we'll be taking the value of P3 comma P1 as well as P6 comma P1, and we will take the minimum of these two values as the value for this new cell, 0.22. Similarly for P3 P6 with P2, P3 P6 for P2. So P3 with P2 and P6 with P2. So P3 with P2 value is here, and P6 with P2 the value is here. The minimum of the two is 0.15. So we write this 0.15 here. And similarly, these two values will be calculated and updated here and here. Whereas the remaining values will be just like that, copied from the previous table. Now this table has been updated. Now this is the updated table. Now again we have to repeat the same procedure. Find out the smallest value in this table. The smallest value in this table is 0.14. Now we'll be choosing P2 as well as P5 for merging. So the data point in the column as well as same row will be chosen for merging. So P2 and P5 will be now merged. So now there will be only P1, P2 comma P5, P3 comma P6 and P4. So this will be removed and instead it will be merged here. And similarly, this row will also be removed and it will be merged here. So after making this merging, what we'll be getting is this type of table. Initially it was like this. So we have identified 0.14 as the smallest value. So this is the table which I am showing here. So same table I am rewriting here. So 0.14 has been identified as the smallest value. So corresponding P2 and P5 will be merged. So you'll be having only one P1 and one P2 comma P5 here, then P3, P6 and P4. Only these 4 rows and 4 columns will exist now. Now again we have to repeat the procedure. So these values are 0 and some values will be retained, like whichever values are not affected will be retained, like P3, P6, these two values are not affected and this value is not affected. P3, P6 with P1, P2, P5 and P4. These values will not be affected. They will be taken just like that. No, just so what will be actually recalculated is whatever is associated with the new change. So whatever is associated with the change will be recalculated. That is P2, P5 row and P2, P5 column. These values will be recalculated. The other values will be actually retained. So the other values will be just taken from the previous table. So P3, P6 with P1. This value will be just like that taken from the previous table, and the P1 comma P4. This value also will be taken from the previous table. And similarly, P4 with P3, P6, P4 with P3, P6. This value also will be taken from the previous table. Only the rows and columns which are affected by the merger, only those values will be recalculated. So P2, P5 is the merger here. Because of this 0.14, we are going to merge P2 and P5. So only the row and column corresponding, only the data points corresponding to the row and column of the merged points will be affected. So we are going to calculate P2, P5 with P1, P2, P5 with P3, P6, P2, P5 with P4. So only these three values we are going to recalculate now. So P2, P5 with P1, that is what is done here, and P2, P5 with P3, P6, and P2, P5 with P4. So these are the three calculations which we are going to do now. So P2, P5 with P1. So we have to break it like P2 with P1 and P5 with P1, P2 with P1, P5 with P1. So these two distances we get from the existing table, and we take the minimum of the two as the new value and update it in the new table. Then for this P2, P5, P3, P6, for this what we do is we take P2 and combine with P3, P6, P2 with P3, P6 and P5 with P3, P6, P5 with P3, P6. So P2, comma P3, P6 is already available in this table. So we'll be taking the value from the existing table. And similarly, P5 with P3, P6 is also already available. So we'll be taking this value also from the existing table. So the minimum of these two values will be updated here. 0.15. Then again we do the last calculation, that is P2, P5 with P4. That is for this value, P2, P5 with P4. So that is P2 with P4 and P5 with P4. So these two values we fetch from the existing table, and we calculate the minimum of the two, and we update it here. So thus this new table has been created. This is the updated table. Now again we repeat the same procedure. So we choose the smallest value for the table. So here you can observe that there are two smallest value. I prefer 0.15 is the smallest value. So I prefer to go with this 0.15 and proceed ahead. So take this 0.15 and merge P2, P5 and P3, P6. So now these two columns will be merged into single column, and these two rows will be merged into single row. Now here onwards there will be only 3 row and 3 column. So now I will rewrite this table in the next slide. So this is that table from the previous page. Now after the merger of P2, P5, P3, P6, we'll be getting only 3 rows and 3 columns. So whichever rows and columns are affected, only those values are recalculated, this row and this column. So only these two values will be recalculated. That is P2, P5, P3, P6 with P1 and P2, P5, P3, P6 with P4. Only these two values will be recalculated with P1 and with P4. These two values will be recalculated now. So P2, P5, P3, P6 with P1. So we'll be writing like P2, P5 with P1 and P3, P6 with P1. So that is what is written here. P2, P5 with P1, P3, P6 with P1. So these two distances are available from this matrix. So we write the two distances and take the minimum of the two and update it here. And similarly for this value, P2, P5, P3, P6. So P2, P5 with P4 and P3, P6 with P4. P2, P5 with P4, P3, P6 with P4. So these values we can get it from the table and find the minimum of the two and update this value here. So again the procedure will be repeated. The minimum of these three values will be chosen now for merging. So 0.15 is the smallest value. So these two data points will be now merged. Now there will be only two columns. These two will be merged and these two will be merged. So there will be only one P1 along with the other data points. and you need to recalculate only this value, which is equal to 0.22. So after this, there is only one possibility. If you want to merge, you only have to merge these two and these two until it becomes a single cluster. So now what we have done is, first we merged P3 and P6, then we merged 2 and 5, then we merged 3, 6 with 2, 5, then we merged 3, 6, 2, 5 with 4, and finally there was only one option to merge everything with this 1. So that is what is represented here. This is called as a dendroid diagram. So this resembles some tree structure. So that is why it is called as hierarchical clustering. Now, where are the clusters here? That is the question. Now we have formed this tree structure. Now, where are the clusters? So you can make the clusters at any level. So for example, if you are going to make the cluster in this particular level, if clustering is going to happen in this particular level, then there will be 2 clusters, and these 2 will be the outliers. Outliers are the data points which do not fit into the normal behavior. So there will be 2 clusters and there will be 2 outliers if we take the clustering at this particular level. Or if we take the clustering at this particular level, there will be one cluster of these 4 points, and these 2 will be acting as like outliers. So based on in which level we choose from the tree, the clusters can be formed. So this is how the hierarchical clustering will group the data points into clusters. So first it will form the tree structure, and from the tree structure, based on which level we are extracting the clusters, the clusters will be formed. So this is how this clustering technique is done. So I'll stop with this for this class, and in tomorrow's class I'll be explaining another clustering technique. If you have any doubts, you can ask me.